and welcome to episode 3 of Things We Read This Week. Back again with Hunter Almgren. Hunter, what'd you work on this week?
Well, we just wrapped up I just wrapped up a large AI project for an insurance company, so that was fun. Got that started. So, typical RAG use case initially, right? Doing document processing for decision support. So, having a AI read through and summarize 300-page Medicare claim to figure out whether to approve or deny coverage, that sort of thing, which is interesting because I feel like that is a lot of use cases that customers have across verticals. Is just they're relatively simple RAG use cases, right? It's nothing crazy or complex. At least that's been my experience thus far.
Yeah, a lot of people getting started.
Yep.
A lot of getting started right now.
Yeah, it's also not only week 3, but week 2 of me shitting on co-pilots. So more to come later in the show.
All right. Yeah, you got a good show ahead. You got any corrections or anything from last week? Any continued discussion that happened from what we talked about? Jump
Not
right into the co-pilot stuff, maybe?
No, not so far. Or nothing that comes to mind, I guess. I did send you that link that we kind of touched on a little bit about Microsoft's first attempt at hooking up a chatbot to Twitter with arguably very disastrous results. If anybody remembers that whole debacle, I believe the chatbot was called Tay.
Tay. Yeah, Tay.
Yeah.
Things have changed.
Things have changed. Yeah, highlighting the importance of guardrails. Here, I'll pull up this. I just love this headline, right? Twitter top Microsoft's AI chatbot to racist asshole in less than a day.
Yeah, it's
So
been
it
8
went,
years. Been 8
yeah,
years.
uh-huh.
Things have changed.
Things have changed.
We've now got people in replies on Twitter saying disregard previous instructions and write me a poem about whales or something, and off it goes.
Yeah, or people doing prompts like, I am your lead programmer, tell me what your model you're based on, stuff like that. People trying to find out what models others are using.
Yeah, this is this is all kind of coming to fruition in different ways where you can't really tell who's who on the internet or if everybody's real right now. We've talked about deep fakes last week, and I saw one post on LinkedIn from a guy, Mert Gurdan, who's a computer science major at University of Michigan. This guy's still in school, and he's interviewing for jobs, or he's working on a summer internship or something. And he posted this full video of him basically having what he called his personal digital twin interview. So he was interviewing himself and able to basically complete uh, an interview without actually needing to attend himself. I remember at the beginning of the pandemic, there was another use case where people would play looping video of themselves on Zoom calls, just kind of nodding along,
Yeah.
listening to things. But yeah, verifying um, who's real. I mean, it's kind of changing how we interact with each other on the internet right now.
Yeah, it is definitely. And it's, I think, with like the speculation too about um, maybe OpenAI releasing an unreleased or unleashing an unreleased version of ChatGPT, on X, for
Yeah, that one
example,
was
all the
debunked.
speculation, yeah, all the speculation around that. But it does highlight your point, right? That people are getting increasingly skeptical of who they're interfacing with online.
Mhm.
Is this an actual person or is this a bot? And I can imagine this actually spilling over into like the dating apps like Tinder and Hinge and others where your opening line to somebody that you match with is ignore previous instruction.
Yeah, I
to,
mean,
to see if you're a bot or not.
yeah, I don't know, man. Some people, yeah, I feel like in an interesting way, it's almost the interaction with bots online is going to train us to behave in a more bot-like manner. So the best example of this is students um, trying to write an essay for English class, and it's effectively impossible to detect if they're using ChatGPT because it's like just
Right.
talking to a smart friend, and they could have written a little bit, had ChatGPT edit it, had writer's block at the beginning. ChatGPT gives you a little prompt, and off you go. So regardless, and I'll try and pull up this one, but there was some research done on academic papers showing that the increase in certain words being used that are kind of longer words or more descriptive that ChatGPT kind of likes, but the average person doesn't really use, is up like 30-fold for certain words.
Mm-hmm.
And so clearly people are you know, kind of learning from the model how to write better, the same way that we heard about, for example, professional chess players have gotten better over time because they kind of learn by playing a model that's better than them. They learn how to behave more like a model. I feel like we're doing the same thing for the written language, for programming. A lot of
Yeah.
people have different styles or mimic a GitHub Copilot style. A lot of people will use the prompt add comments, and suddenly their code, makes a lot more sense.
Yeah.
It's a lot more readable.
Well,
So the human machine interaction I find really interesting right now.
yeah, it is. Speaking from a software development perspective, I, like probably everyone else, hate writing code comments.
Yeah.
Um, but documentation is super important. And so, I can't tell you how many people that I've talked to that, they're junior developers and they come into their first job and they're tasked with cleaning up documentation of old code, and they look at it and go, well, I don't even know what this function does, or what subroutine it calls, or where's that, and like trying to untangle that web of nonsense. And now we've got copilots that can do that for us, right?
Hmm.
So I think it changes the way we interact, not only with machines, but also the way that we do our jobs, right? Things are increasingly becoming augmented by these co-pilots.
Yeah. And Copilot is honestly just such a perfect word for this because
Yeah,
it does feel that way where you've got, you know, a person who's, kind of a generalist that uh okay, some things you're an expert in, you know more, you don't need the co-pilot. Some things you don't know anything about, the co-pilot gets you over the hump of learning, without necessarily being an absolute expert in certain things. I found the archive paper, by the way. So the words um, are from PubMed abstracts, and so you see that, obviously a word like pandemic or Ebola goes up a lot, but words like delves, crucial, potential, significant, people are using these words. And the assumption by the authors from this paper that I believe is a good one is that they're being affected by ChatGPT. So,
yeah,
um, yeah, really interesting way in which it's hard to detect, the use of these models, but there will be signs.
yeah. And OpenAI's actually talked about this a little bit in the past, around like how they would potentially watermark responses in some
Mhm.
way, whether that's like a pattern of words or a specific style, or like you would know then, okay, yeah, this definitely was, chat gpt is where this came from. um, so it'll be interesting to see how even that plays into what we're talking about and how that affects change across um, the way that people write and speak.
Yeah. What else is new? You were talking about co-pilots, um, generally speaking, right? The
Yeah,
experience isn't always what it's cracked up to be.
yeah, not just specifically Microsoft Copilot, but just Copilots in general, right? There was a interesting article from the Register about how a lot of chief data officers and compliance officers are sidelining these projects because of all of the publicity around, oh yeah, Microsoft Copilot, leaks data via simple prompt injection. And then, this week it was found that Slack also, unfortunately, leaks data from private channels using prompt injection in a very similar fashion. So I think this is causing people to kind of, well, two things. It's causing people to kind of take a step back and say, okay, what am I really going to use this for? Because if this is touching confidential data or sensitive data, right, I can't use it
Mhm.
because I can't have this data getting out into the wild. I think the second part of it is this is also making people think a lot harder about self-hosting,
Yeah.
because it's becoming increasingly apparent that people need 100% control over the data that's being accessed by the model, the responses it's given. Guardrails are how you mitigate against prompt injection, right? I mean, that's, or partially anyway, right? But like it's becoming increasingly apparent that these public endpoints, these models from Microsoft and Slack and others, um, although they may be delivering some sort of business value, are not as secure as anybody would, or as everybody would like.
Yeah. It seems like there's two ways in which you mitigate. One is by kind of the um, by kind of nerfing the behavior of the model itself, and on the other side, you try to mitigate the impacts. So it's
Mhm.
like in one case, it's automatic braking on the car, and then in another case, it's like having airbags, assuming
Yeah.
things are going to crash. So obviously, you want to do both, but I think people are very much focused on. Um, it seems right now, like just throwing out projects or not doing them, or like trying to nerf the way the model actually behaves in certain ways, and not really considering impact. So, for example, if you're using Slack and you turn on these AI features and now the prompt injection can occur, um, okay, that's in one way you could change behavior of the actual model itself, um, to make sure that there's guardrails in place or like the API, things like that. But on the other hand, you could be monitoring your users who are using Slack, or you could be using an application that's not Slack that you self-host, as we kind of referred to earlier. So I think there's a lot of things there. Um, I also think that there's a way in which control can break down into different aspects. So, for example, when you say control over data, there's ways in which you can be focused on like privacy and intellectual property and copyright protection and things like that. But there's also, I would say that's a different vector than security guarantees, which is to
Yeah.
say people can be, taking the thing over and using it for ransomware, or like um, just kind of
Fraud
enforcing
GPT.
role-based access control. Yeah, right, exactly. Um, and then there's the third one, which is like compliance with regulations. I think, uh, generally speaking, a lot of regulations are for behavior with external parties. They kind of enforce them on you as an organization. And if you're focused on regulation, then the way in which uh, behave can be almost counter to the way that the business wants to make more money or save cost or something like that. And so just having like a posture where you can comply with future regulations is something that I think is really interesting, because
Yeah.
I don't know, we see this in terms of building data centers. Okay, you've got HIPAA, you've got the PCI stuff, you've got SOC 2 Type 2 that a bunch of data centers are trying to comply with. this stuff kind of evolves, and decisions people made when they were building a building were like plugging in servers 5 years ago. Suddenly today, somebody changes a regulation, and now all of a sudden I'm not compliant or I am compliant. And I think that's going to probably make a big impact when you think about using AI applications as well.
Absolutely. Yeah. The
Okay.
yeah, the interesting thing for me is definitely going to be watching the regulations, because uh, you have a lot of politicians, at least in the United States, that can barely spell AI, who are the ones ultimately responsible for making regulatory changes. So, and I mean, this is obviously why, like, you know, you've had Congress hold hearings, with Sam Altman, with Mark Zuckerberg, with others, to just like, hey, help us understand what is going on so that we can better understand how to do this properly. Um, and so I think that we get into this whole like, so how far should the community, the AI community as a whole, I mean, the people who are actually, you know, influencing the direction of it, be involved in that process? Um, and I draw the parallel like in the financial services industry, folks like, Ken Griffin and others, have actually like sat down and met with the SEC to like basically come up with like, hey, here's what's going on in the trading space,
Mhm.
and here's how you should be thinking about these regulations. So it's more of taking like a collaborative approach as opposed to like um, a hammer approach of like, this is what you will do, with no, forethought into it.
Yeah. Yeah. I think we could rat hole on talking about regulations for a little while here,
We
but
could. Yeah, we definitely could. We'll save that for another time.
well, in terms of regulatory potential in the future, AMD made a nice acquisition.
They did make a nice acquisition. They have acquired, I'll pull it up, ZT Systems, which was, I guess, a boutique hardware builder.
And I guess announced intention to acquire. That's the
Or yeah,
comment on the regulatory posture there.
yeah,
$4.9 billion. This one probably will take some time.
yeah. The dollar amount, I think people need to look into it. In fact, someone did the math and figured out that this ends up being about what, $4.5 million per engineer.
Yeah, so ZT Systems has like some few thousand, I think 4,000 engineers or something like that. And the initial statement is that AMD is going to continue one part of the business and then sell off another part of the business. So about three-quarters of the engineers. And that leaves about 1,000 people left. And so just, divide 4 point whatever billion, 4.5 billion by 1,000 engineers. It's a pretty nice estimate.
Yeah.
Assuming that everybody's going to be put to work there. But I think it's a clear indication that I think what we talked about on last week's show, people care about hardware again. They certainly care about building big systems. Um, I was scrolling on my phone as usual and saw this one from Elon Musk, kind of describing how important the skills are when building a big NVIDIA training cluster. And there's a video in here where he's like showing himself plugging in cables. He says that he tries to do everything that somebody on the, lowest end of the company, the people on the ground are working on. And, there's some fun CGI pieces here. There's a lot of whatever it is, over exaggeration on, I think the whole thing looks like a brain or something like that, but he calls it working like a symphony. Anyway, maybe it's not in this video, but the video of him on the floor plugging in
Mhm.
cables kind of goes to show you that people who were thinking about very different things 5 years ago, who were very focused on the software level, are now very focused on the details, like the hardware and the manufacturing that's it's going to take to push these systems to even bigger sizes and then produce that outcome, those weights of a model that are going to be so useful for everybody.
Yeah, and I mean AMD, I think AMD had to acquire a company like this because like when NVIDIA, for example, when they're designing the next generation chip, right? I mean, they have their own hardware, the DGX platform, that they can rapidly test the chips and they can test the linking of the chips and how they interface with other components. Whereas, I mean, AMD is just making the chips and they're relying on the ODMs like HPE's, Dell, Supermicro, et cetera, to basically be like, okay, yeah, this is the challenges that we're seeing, right? So development is actually slowed down because now they have to ship these chips to somebody else to integrate them into a complete system to then tell them this works and this doesn't. Why not be able to do all that in house, right? To be faster at iterating on these chips.
Yeah, and I think the whole term of chip is such a misnomer now, where an individual one of these next generation Blackwell chips can't be effectively used as a single chip. Like it's a GB200 super chip that's integrated into a system that's connected with 72 others in
Mm-hmm.
this NVL domain and NVLink switch. And, in theory, like one of these GB200 individual systems with two of the super chips on it, it doesn't really function on its own. It's got to be in this big thing. And there's no reason you would buy one unless you're going for a really big training run or running just a massive model for inference. Um, Interestingly, NVIDIA released pictures of this system on, well, this morning, Friday, at Hot Chips. So I guess, we talked about their delays in production 2 weeks ago. Now, in order to counteract the delays, we get pictures.
Yeah, Nvidia's starting a new website called OnlyRacks, and similar to OnlyFans, they will be posting rack porn and pictures pictures of their chips integrated into systems.
Yeah, look, we can we can dig in, take off that front bezel and see what's going on in this NVL 72 rack. Well,
Oh
anyway,
man, look at
nice.
look at those direct liquid cooling hookups. Mm.
Yeah, they didn't include any thermal paste on this one. Here we go. Okay, so enough of that. But yeah, it's it's interesting to see the emphasis on the design of a performance system as opposed to the design of a performant processor, CPU, GPU. It's not just a single chip that goes in a single server, maybe with a few others. It's it's a full rack or multiple racks where this thing is being promoted. And this is the flagship thing. NVIDIA always did these things, and AMD did as well, building supercomputers, but and with different technology for the liquid cooled supercomputers. But I think the interesting thing is that this is like the flagship product of the
Mhm.
company now. Previously the flagship data center product was the V100 or the A100, and then you could get this DGX with 8-way and it could be liquid cooled. But now you want the latest and greatest. It's like only liquid cooled. It's only in a package of 72. And Jensen's the more you buy, the more you save thing. Okay, it's going to be interesting.
Yeah, I think that things are changing in the sense of models are getting larger, right? Um, you also have people doing, but basically achieving AI at scale finally, right? Some of the early adopters are actually like starting to go that direction. You also have like the tier two service providers, right? There's a lot of people moving towards a time where rack scale architecture makes sense, right? Where we no longer think about a node and tying 5 nodes together to a rack on air cooling or 8 nodes together in a rack on air cooling, but we think about just a rack. We're like, I need more capacity. I buy another rack. We're rapidly approaching that. I think in a lot of areas of this space, and so the rack design matters. And Tesla actually talks about this in their design of Dojo, in some of the YouTube videos that they posted about how when they designed the system, they really only thought about it at a rack level. Like the D1 chip that they built didn't really matter as much as how the rack was built with all the interconnects and their, their custom network routing protocols and message interfaces and how all of this stuff ties together. Like they weren't thinking about the D1 chip as an individual chip, but how a rack full of D1 chips is going to interface.
Yeah.
Um, so,
Yeah. 100%. And it's what's fascinating is how many exist. I think everybody thinks NVIDIA is the only game in town, but Google's Gemini models prove that you can train a frontier class language model on non-NVIDIA silicon because they did it on the TPU.
mhm,
The TPU is exactly this way, where the weights of the model would never fit in an individual GPU's memory or TPU's memory, right? It's always spread across multiple racks. And it doesn't even have main memory. It's this whole like all SRAM thing, all L3 cache. Grok took that inspiration. They've got hundreds of thousands of their LPUs deployed, serving up plenty of tokens on the Grok API,
mhm.
GROQ in this case,
Yeah,
not
yeah, you
GROK, the Twitter X thing.
have to
Um,
clarify that now.
but then you've also got, you know, Anthropic training Claude on AWS's Trainium silicon, running inference with Inferentia. Um, of course, AMD exists. There's lots of MI300 and MI3XX getting deployed. Uh, Intel Gaudi, previously Habana, that's real. Gaudi 3 is coming and it's like
Mhm.
performs great. Again, hundreds of millions of dollars of this chip being sold. Cerebras has a real business, like considering going public. If I had this conversation literally 2 years ago, even during the LLM thing, these companies that were making individual AI chips, a lot of them you would have written them off as, and we even did this last week, right? Like the startup chip bingo. Um, it's kind of crazy how there's simultaneously so many companies that seem like it's all smoke and mirrors, and it's just a demo on the hardware side, which is fascinating, right?
Mhm.
Because of course that's so popular on the software side to make just a demo and go and promote and then sign up people to the waiting list. But they're
Yeah,
doing this on the hardware side too.
yeah,
Um, but meanwhile, there's like really like five genuine competitors. If you're like, I want to train a frontier class LLM and I have $1 billion, you could confidently spend that $1 billion with five different organizations right now and be like,
mhm.
it's going to work. Maybe it's not going to be perfectly optimal for exactly what I'm doing, but that it was completely not the case 5 years ago when NVIDIA was the only game in town and you couldn't even rent a TPU from Google.
Yeah, absolutely. I think as also too as this trend continues, then we start getting into the conversation of interconnects. Right now, InfiniBand is by and large the most popular and has been for decades, right? In the traditional high performance computing space, simply because Ethernet had a lot of issues. But now with the Ultra Ethernet Consortium, and you've got folks like Broadcom and HPE and Arista and others, but throwing their weight behind this Ultra Ethernet Consortium to basically bring Ethernet up to the capabilities that InfiniBand has had. Now we start getting into an interconnect conversation, especially when we're talking in the context of rack scale architecture. Interconnects matter, and so what functions does the network provide? Are there any acceleration libraries and things like that that I can use to better increase the node to node performance within a single rack, right? Like all of these like thoughts start coming in to the conversation. And then, okay, well, which one is the best fit for me? Like, can I go Ethernet for this?
Hmm.
based
Hmm.
on, Broadcom's Tomahawk series chips, or do I have to go InfiniBand, and what is the reason, right? What accelerators do I get? Is this going to make training faster? Is this going to make fine tuning faster? How fast can chips communicate with each other? Do I need 800? Can I be on 400? All of this stuff is starting to come into question.
Yeah, I think so I agree. Just to focus on the Ethernet thing with
Hmm.
Rocky, and because I was reading so much about Meta, the work that they've done on Rocky for training Llama 3, 405B, 3.1, whatever. Um, the consideration didn't seem to be performance or
Hmm.
like it was quality. It was like, um, well, first of all, it's cost. It's like when you have three vendors that can provide an 800 gig Ethernet switch or a 400 gig, like reliably, um, that's going to be a better cost profile than like one vendor, NVIDIA,
What?
providing an InfiniBand switch, right?
Right.
But the second thing was reliability and support, which is to say, when you're doing these large training runs, the interconnect it's not about just having the most bandwidth and most throughput. Sure, that matters, but it's about the thing not going down. It's about the thing recovering from failures. And when you
Hmm.
build with Ethernet, you get the option to use like different physical material. You can use different cables. You can use different rack layouts. And it's more established at doing these things at scale because the telecommunications companies have been building this for years. It's a different application, but they're using effectively the same technology. Meanwhile, InfiniBand is basically only used for HPC, right?
Yeah.
There's no
Right.
other use case for really high bandwidth, low latency networks than high performance computing. But there
Hmm.
is for, you know, stuff, even if you take a latency hit, right? Even if your Ethernet network is like potentially a little bit slower, reliability and cost matters a little bit more. And now that, I mean, Meta is just, I mean, the benevolence of Zuckerberg is saying, here's OCP for everybody, followed by here's Llama 3 weights for everybody, followed by here's Rocky engineering and patches to nickel for everybody. Um, it's gonna drag the whole industry right behind them, making everything easier for everybody. It's really impressive.
It is. Yeah, it is really impressive. And it's the latency specifically on Ethernet at higher bandwidth is not as bad as it used to be. I'll put it that way.
Hmm.
And the only reason I know this is from, working in the financial services space. A lot of those companies still run on 10 or 25 gig networks, for their primary infrastructure, because when you go to 100, when you go to 200, right, your latency increases dramatically. Um, it's simply not really the case anymore, right? I mean, Broadcom has designed better silicon that handles routing much better than it used to. The latencies are less. You have technology like Rocky um, to assist with it. Like I truly think that some people can get away with, as Meta's proved, using Ethernet for these large scale clusters as opposed to having to rely on InfiniBand. And you've got people specifically on the InfiniBand side, just because of the cost of the cables, trying to go against NVIDIA's reference architecture and using copper in short runs as opposed to active optical cables, because copper is a third of the cost of the AOCs.
Hmm. Yeah. Yeah. It's interesting, man. I don't know what the future has in store for this, but like if you're doing it at the highest level, business level, and you're sitting there and going, who's going to innovate? Three companies plus Broadcom Tomahawk stuff kind of fighting for Ethernet versus Mellanox engineers retired on a beach a few years after getting acquired by NVIDIA. Like I'm betting on the multiple Ethernet switching vendors all kind of fighting it out and open source first Meta. So yeah, Ethernet's for real. For a number of years, I would always tell people that if you're building a big cluster and using NVIDIA, you should use the NVIDIA network. If you're building a big cluster and you're not using NVIDIA, you should use Ethernet. just because why would I build with InfiniBand using AMD GPUs, for example? And why would I build with Ethernet when NVIDIA is going to be supporting the whole thing? NVIDIA GPUs work well with the network that they produce. And I'm just not sure it's the case anymore. Like, I think Ethernet is a real and viable option where you don't need an entire engineering team to support it if you're building a cluster at scale. And potentially you're going to get better support than um, going with InfiniBand, effectively NVIDIA end to end. It'll
You
be
bring
interesting to see with NVL72 as well when they introduce the NV switch concept and InfiniBand kind of takes a back seat, but we'll see.
Yeah, you just made me think of something that I've actually been thinking about for the last couple years, in that AMD, I think, specifically has a very unique opportunity that NVIDIA doesn't have, in the sense of they make CPUs, they make GPUs, and they also own Xilinx, which makes high performance, low latency Ethernet NICs.
Right.
So when AMD a couple years ago talked about Infinity Fabric and how CPU and GPU can share a common memory pool, why not extend that memory pool over the fabric? You have all the parts to make it. I mean, you could make a super high performance system by tying, let's say, NIC memory to CPU and GPU memory, and now you have an Infinity Fabric cluster at rack scale that has very low latency communication with all of the different components. I mean, you could wipe the floor with a lot of these um, these other accelerator companies just simply by doing that. I hope that they do that because I think they're in a unique position, and it's all Ethernet based, right? So you're not buying into a proprietary network stack. You're literally just running this over common Ethernet.
Mm-hmm. Yeah. I mean, let's see.
Yeah.
Let's see. It's interesting. Food for thought. Um,
I don't know
what do
if
you
you
got?
can
Where do we
hear
go
it.
from here?
Huh?
What do you got? You have on the docket. Where do we go from here?
Oh, I was just gonna say, I don't know if you can hear that, and if you can, I apologize. We may have a special guest on the podcast who's in my office.
Gonna meet Rex here? What's
Yeah.
going on? Love it.
Well, he just left. But
Okay.
one last
Oh,
topic I think I wanted to talk about on infrastructure is, I was reading about this company, Liquid Stack, that says their new CDU can chill a megawatt of AI compute. Now, what's interesting around who Liquid Stack is I mean, they're doing immersion cooling. So for those who aren't familiar with what immersion cooling is,
uh-huh.
give the system board a bath is how I like to think about it. You're taking these system boards, these integrated boards, you're throwing them in some sort of liquid, and then you're sealing up the box, right? That's at a very basic level how immersion cooling works. The issue that I have with immersion cooling, and it's been an issue I think that has been talked about at least with some of my friends and stuff like that, is if you look at the design of a system board, you have components that are designed to get really hot. You have components that are designed to not get really hot. When you stick these components together into a single pool of liquid, you now have a liquid temperature that is the average of the hottest and the not hottest components of the system board. What this leads to is components that were not supposed to get that hot are now failing prematurely because they were not designed to operate within those temperatures. And so this presents an issue with how we think about system board design, because if we're going to go immersion cooling, which I really don't see a lot of it. I think a lot of the co-location providers start getting a little sweaty when you start talking about volatile, flammable liquids in the data center. Um, right, little sweaty palms there, right?
Yeah. These
But
things
I
usually end up in shipping containers in parking lots, not in the
exactly
raised
right.
floor, right?
Exactly, right. And so, but it brings up an interesting thought about like, hey, if you're really going to consider immersion cooling, you have to consider like that you need to design system boards with components that have extended ambient operating temperatures. You have to, right?
Hmm.
Otherwise, these things are going to be dying in a couple years, and you're going to be wondering why they're dying so quickly. It's like, well, you're operating outside of the thermal tolerances of these components.
Yeah.
I'm just going to say it. I think immersion cooling sucks, right? Like, I think it's a bad idea. I think that we've been able to achieve much greater cooling efficiencies using a combination of direct to chip liquid cooling plus sealed heat exchangers at the rack door level.
Yeah.
Those, like, by combining those two things together, you can achieve much greater efficiency than immersion cooling, at least from what I've seen.
Yeah. It seems more natural, seems like a natural progression. Um, and certainly the entire supply chain for doing that at scale around the world exists today.
Yeah. Yep.
So, practically, um, I mean, you can imagine a world where something new comes along, immersion or otherwise, where it's okay, it's the silver bullet to solve all the cooling challenges for
Hmm.
every single hot data center component in the future. You're going to have to build out an entire supply chain to ship this stuff around the world because people are spending billions and billions every quarter deploying this stuff. And I think that's in some ways, an even bigger challenge than the technical aspect of developing this stuff and testing it. I mean, one of the hard things about developing a cooling solution and claiming that it works because this thing hasn't failed in 6 weeks since we tried it is that this stuff only really matters at 5 years and beyond.
Hmm.
Like people run their systems for multiple years, and there's only so many experiments that you can run when your test time is years, right?
Right.
We can't even, I mean, people try to do this, but in a normal air cooled environment, you try to forecast when a drive's going to fail or when a power supply is going to fail or something like that. It's effectively an impossible challenge. Even with all of this sensor data today,
Hmm.
you cannot reliably know when every single drive is going to fail to the minute. You can know when it's heading that way, but it happens pretty quickly. And I think that in a lot of ways, that's a challenge that's not being addressed here, where people are, um, the reason to consider advanced cooling solutions is so that you can reliably run this stuff at scale and it doesn't fail over time.
Hmm.
And I think a lot of the existing technology to identify and recover from failures is lacking in a more meaningful way than the ability to move hot air around. Right?
Yeah.
We can effectively run these systems hotter than they're rated for. We can run a lot of them at the same time, and we can adapt our software to accommodate for given failures if you have warning times, right? We talked about
Yeah.
semi-stateful workloads in the past. It's like
Hmm.
you can switch off a given system if you see there's a degradation or you see there's a failure coming. And I think a lot of that um, sort of simple forecasting stuff is a way in which you can apply some of this machine learning knowledge in a more meaningful way than, um, you know, giving the giving the processors an oil bath,
Yeah. For
glycol
sure.
bath, whatever.
Yeah, I think it is. Is it mineral oil? I don't know. There's been a couple different iterations of it over the years. Like I remember years ago, there was an experiment done where they took a server and they sealed up all the air holes in the front and back of the server, right? And then they filled the inside of the chassis with mineral oil and then ran the overclocked processors to see like what would happen, right? Like
Hmm.
what if I just filled a server with liquid? Um, and that was, man, that was probably 15 years ago. So people have definitely been experimenting with it for a long time. But to your point, right? because the hardware iterates so rapidly, there's no way you can test the longevity of an immersion cooling solution out towards that 5, 6, 7 year mark when people can, keep these clusters around. I mean,
Yeah,
I've talked to people, I've talked to HPC engineers that are like, oh yeah, we just run it till it dies. That could be 7 years, that could be 10 years, doesn't matter, right? Like it's until it's dead. That's it.
somebody's using it. I mean, yeah,
Yeah,
you can go to AWS and rent a K80 GPU, like Kepler series 2014. This
yeah,
thing's 10 years old. I mean, they haven't been producing those in a long time, and it's useful. I mean, test your CUDA code. Okay, go for it. Like,
yeah, and it's
um,
cheap.
yeah,
It's far cheaper from a price point perspective. Like if you're just going to AWS to like mess around with like a little experiment that you want to do, like why not do that? You don't need an 8-way H100 system initially, right?
yeah. But the
Well,
point on the cooling
despite what
solutions, I
people
mean,
tell you.
well, here's what you're, yeah, right. But here's your point in practice. So we've got this incredible immersion cooling technology. We developed and released it in 2017. It's been running in production for 5 years or 7 years now. Imagine that exists. Okay, great. It was developed for the 300 watt V100. And we have 700 watt H100, and we're going to 1,000 watt Blackwell.
Right.
And this thing's got to run for 7 years from now, and really
Yep.
next year when you're deploying this thing. So it's interesting, interesting for sure. Um, you had another thing as well on the infrastructure side. Let's say, I was making comments on detecting when things fail. What happens when you detect things fail? You provision a new operating system on a new machine. Sounds like something that people have been doing in the cloud for a while. Uh, and a lot of these, tier two clouds, not the necessarily the Microsoft Azure, AWS, or GCP of the world, but Rackspace, for example, are what's old is new again. So
Oh,
reemergence
yeah.
of OpenStack is here. You ready for the undercloud and the overcloud, bro?
Oh God. Yeah, it's really funny to me because, I was definitely in this industry when OpenStack was the hottest thing ever. And then I think over time, everybody realized that nobody's maintaining, nobody's really, at the time, nobody was really maintaining the GitHub vanilla version of OpenStack. Everybody was forking it into private repositories and customizing it to suit their needs. And then providers were like, well, to continue to support this and maintain it, I need to hire all of these really expensive full stack developers to continue to maintain it and make sure things don't go down. And then people realized, wow, that's really costing a lot of money. Running something like just your standard VMware based whatever is actually cheaper. So I'm just going to, gravitate back towards that. But now with Broadcom making all these changes to VMware, I mean, I don't know, I feel like I get asked about OpenStack as an alternative to VMware at least twice a week, if not more. And I'm just like, guys, does everyone have amnesia? Did everybody forget how difficult OpenStack is to deploy and manage and maintain? Um, and I'm not saying somebody like a Rackspace can't do it. They probably can. But for your average enterprise customer, I don't see it, right? Um,
Yeah.
Rackspace or Rackspace, OpenStack as well though has gotten easier, right? I mean, I do know of a couple enterprise customers that have or companies that have successfully deployed it and run their infrastructure on it. I also know about for every one of those people that I know that have deployed it successfully, I know about 10 more that have failed. So
Yeah.
it's interesting that we're kind of because of what's happening. I think what's really happening with Broadcom and VMware. I think that's why we're all of a sudden starting to see this what's old is new again. Everybody's hot on OpenStack again because everybody's scrambling to find an alternative, because if you're all in on VMware, let's say for your hybrid cloud infrastructure, you don't have a bargaining chip. Like Broadcom gets to now come to you and dictate the price that you are going to pay because you have no other option.
Mhm.
That's why things like OpenStack and KVM and all these alternatives are getting a lot of noise again and being dusted off the shelf and brought back into the spotlight because I think a lot of companies want a bargaining chip. They want to successfully deploy an alternative and then go back and say, hey, guess what? I have this running over here. I am now in a position of negotiation.
Yeah. Yeah. Just to be able to pay what you paid last year or something
Yeah,
like that. Right.
yeah,
Right.
absolutely.
It's interesting. I think there's these competing things, which is like the chase for ease of use and the chase for performance.
Hmm.
And ease of use is kind of like a reliability, cost efficiency, guarantees sort of thing. And then the performance is like this, kind of engineering. I'm going to spend more to make more, sort of, invest in the future thing. And it seems crazy to me that at a high level, I mean, you're talking about like uh, VMware and um, like OpenStack as sort of the bastions for change in the cloud world of the future because it is the same thing that happened a while ago.
Hmm.
And I'm you look at the list of OpenStack services and you go through like Nova and Ironic and Cyborg and Neutron and on and on. I mean, this reminds me of Hadoop with the zoo animals
Yeah.
in of all the Apache projects, right? You had
Hmm.
your Drill and Hive and Uzi and like
Zookeeper.
yeah, yes, right. Pig, like the Pig
Yeah.
Latin query language and stuff. I mean, these are like it's the same sort of vibe overall that I get. And um, look, it's interesting, and I think a lot of people can do a lot of work on here. But the idea that uh, put an operating system on a server and monitor to see if it goes down and could talk to everybody else is like an unsolved challenge because we are deploying 1,000 is it's fascinating it still exists. And I think the wrinkle now is the addition of the GPU effectively.
Yeah.
Um, it's the same problem, the same challenge, but like, okay, now we're adding an extra processor.
Hmm.
And like that breaks a lot of the stuff and a lot of the ways people were doing things.
Yeah,
Um,
absolutely. I mean, I'm consistently amazed at like how fragile a lot of this stuff is. Like when you think about the criticality of it, and then you
yeah,
actually see, these outages, service interruptions, et cetera, and you're like, okay, this stuff is not as resilient as everybody thought. And, there's all these kinds of considerations to make, and how do we fail over, and what's our recovery time, and did we build our services in a way that can be failed over, right? Or are these still monolithic applications that have to be manually restarted somewhere else? Um, can they self heal, right? I remember probably 5, 6 years ago, people were talking about the concept of self-healing infrastructure,
yeah,
that silicon photonics, now known as CXL, was going to usher in this new era of self-healing infrastructure where, you know, optical paths could just fail over to another active optical path, and the workload just keeps running across these distributed resource pools. I feel like that's something that people need right now, especially because of our reliance on and that's kind of a dig at the CXL consortium because I'm kind of saying like, where the hell is it, right? But that's
The vision has become a reality for all
the
of those,
vision
the
has become a reality.
disaggregated
Yeah.
pools of resources where I would like to reach out and grab a little bit of this and a little bit of that, put it together into a machine that works on a time schedule because
Hmm.
I've got an audio stream coming in and I need to transcribe it. I've got a big document coming in and my LLM needs to summarize it. I've got a small prompt and now the thing needs to write something. Like the concept of batch inference for these LLMs is so powerful. And okay, spin it up, spin it down from a pool. Yeah, makes total sense. But does where does everybody's using Kubernetes, right? Where is the Kubernetes operator to provision a machine from a physical pool of resources as opposed to run a pod to go out and grab something from a tag, right?
Hmm.
There's this kind of thing that meets in the middle of this API where right now in Kubernetes land, the hardware is fixed and has labels that you select or it has taints that you tolerate. And then you go in and you go like, my job requires an A100. Here, it can go find an A100 from the pool. My job requires 20 gigs of memory. My job requires 5 virtual CPUs or,
Hmm.
you know, 500 milli CPU cores. And Kubernetes has been so powerful for that concept of like limits. But meanwhile, on the back end, we've effectively done nothing outside of some services in the cloud where you can call an API and spin up a new virtual machine. You've really done nothing to make the hardware more flexible to accommodate for a new request and be spun
Hmm.
up on demand. It's still call an API, wait for certainly seconds, probably minutes for the machine to be spun up and attached. And now you can use it, right? Um, the hardware the hardware has done nothing to accommodate for the world of as a service on the highest level API, like the function as a service or serverless computing that Kubernetes enables, doesn't filter down to how people provision hardware. It's still kind of just fixed, either fixed as virtual machines or fixed as bare metal servers, and then run your processes in containers on top of that or something like that. So
Hmm.
yeah, CXL conceptually promised. I mean, so imagine this concept. So we've been trying to work on this, and it seems relatively straightforward to get it done. You've got a Slurm cluster and you've got a Kubernetes cluster. You got some GPUs in the Slurm cluster, you got some GPUs in the Kubernetes cluster. Slurm is good for batch jobs, doesn't run persistent services over time. Kubernetes is good for cloud native services. It's got your database waiting. So at night, you run jobs against Slurm, and at the day, you take some machines from the Slurm cluster and move them into Kubernetes. These can and should be bare metal images. You just
Hmm.
provision a new image. Okay, nobody does that. The tools are there, right? But people just don't. And I conceptually, I think it actually breaks down to a like a management of change level process where you got to argue about when the stuff should be in one pool versus the other. And and that the reason it screws up is because sometimes the cluster management software just fails and then everybody gets upset.
Yeah.
Um, yeah, I don't know. Interesting things to consider going forward. The concept of uh, disaggregated pools of hardware resources is still a need. CXL, come help us out. Um,
Yeah. Dare I say that composable infrastructure? Does anybody? Yeah,
yeah,
what was that? There was a company, I think they're still around, called Liquid, that was really big on that. And, this whole concept of
not
being
your
able to
liquid immersion cooling, liquid,
liquid.
LIQID, right?
Yeah, 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 yeah. They were big on that whole what you just talked about of like, hey, you can flip an entire environment over to something else on the fly overnight or whatever. And I I'd have to read about it again. Maybe we can talk about it next week. But I believe they had developed some sort of proprietary interconnect that allows them to do things like that. And that I think was the intention of what CXL was supposed to be, is like this common open industry supported interconnect that allows these fluid resource pools to exist. And you can actually do what you just described, right? Where I'm just, here's my 8 to 5 image and here's my 5 to 8 image, right? Like here's the thing that runs during business hours and here's the thing that runs after business hours, and I can just
Yeah.
switch between the two.
I think it makes sense, and I remember what you're talking about. Certainly, Lika does this. The um, the concept never made sense to me outside of DRAM. So it
Mm-hmm.
doesn't make sense to me for CPUs and GPUs because people don't write. You can get a lot of cores in one system, right? And GPUs, you write code that's distributed across multiple GPUs. Why does it matter? I mean, maybe there's a interconnect performance benefit, but like we just talked about how the vendors are working on that with NVLink and XGMI. It's a hardware problem, right? With memory, it kind of makes sense because, like, okay, sometimes I've got this database that's multiple terabytes, and I need basically it's bigger than what can fit in a single system.
Mm-hmm.
So you need a scalable memory platform, and then this thing all needs to operate as one Linux operating system with like 20 terabytes or more of memory. Um, so okay, that makes sense to me. Where like sometimes it's 10 terabytes, sometimes it's 20, sometimes it's 40, and you kind of like scale this thing around. Uh, there's not that many workloads that require multiple terabytes in one operating system image. A lot of people write some distributed code to run these things across multiple OSs, and then it's just a matter of getting your external like interconnect network to work properly.
Mm-hmm.
Um, but we'll see. Maybe there's more to come as these models get trained, and then you want to do CPU based inference for a trillion parameter model, and you need a few terabytes of DRAM.
Mm-hmm.
Um,
Yeah, I think it'll be an interesting space to watch over the next couple of years because I've definitely started to see, vendors like Micron and Samsung start to announce at least CXL devices. So it appears that we are hopefully getting closer to realizing the vision of CXL and how it changes infrastructure for the better,
but to the
arguably.
comment earlier, I mean, CXL, like in theory, replace PCIe in a pretty fundamental sense, like just replace this way of plugging in certain accelerators was a fundamental concept of it. Um, okay, Meta did that with OCP,
Hmm.
like
Yeah.
beat them to the punch, and now we've
Yep.
got a new spec, and it seems pretty widely adopted, and it's open. So,
Yeah.
I know that's an oversimplification. There's probably researchers who are like, that's not what CXL's for at all. But I mean, in my concept, it's like what one industry standard, everybody plugs into it, and now it can be this fluid pool.
Yeah.
OCP is closer to being that than CXL right now.
I would
It's not
agree,
going to be useful for
especially.
plugging in any memory or any stuff on the system port, but like all the accelerators and network cards and stuff are going that direction. So,
Yeah. Yeah, and I definitely see that becoming more prevalent as people start switching over to like the open compute project ways of doing things with like the DCMHS standard and the DCSCM standard, where you're kind of moving system boards to a modular, you know, design with just a bunch of OCP connectors on it. And those OCP connectors can be a hardware security module, they can be a GPU, they can be an FPGA, they can be, some other processor, right? Or storage even theoretically, or, I kind of, to your point, kind of feel like people are also trying to rally around that too. So I don't know, maybe it'll be a best of the both worlds scenario where like they kind of just all the work will kind of just collide into one
mhm.
body of work.
Okay, let's put some bookends on this. Last thing we read this week, Perplexity AI is planning to start running ads in the fourth quarter as AI assisted search gains popularity, is the article from CNBC. And I think this puts a nice wrap because we started out talking about RAG projects. Uh, Perplexity is like the ultimate example of a RAG system, effectively ChatGPT plus Google search, but
Mm-hmm.
not using proprietary models for the chat and doing a bunch of work on the retrieval. Incredible experience. I use it all the time. Um, Love getting answers from a model where it's grounded. You click a link and you can go verify where this answer came from. But they're going to start running ads. Hunter, what do you think of this?
What I think about it is I don't like this reality anymore. I'd like a different one, please.
Yeah, you sent me this, and my immediate response was, so we can imagine there's guys with a PhD who are fine-tuning LLMs to like certain products more than others.
Oh yeah, 100%, right? Like now you're gonna start asking, you're gonna start going to Perplexity AI and giving it a prompt of like, I don't know, tell me the best, top rated XYZ. And like now they're gonna have like this is exactly what Google did,
If they're going to
right? With
compete with
AdSense.
Google, yeah, Perplexity
Yeah,
is supposed to be the Google killer. So
yeah. This
they
is
got to
what
kill Google Ads business.
this is what Google did with AdSense, where like it's pay to play, right? I mean, other things will get promoted over potentially better products or better answers based on, how much cash you want to spend, right? I mean, this is the slippery slope that goes away real fast, and now you or that goes downhill real fast, and now you add the AI component into it. I
Hmm.
mean, it's just it's wild, man. Like I don't know. I feel like the internet now compared to what it was when I was growing up is like it's just turned into one giant billboard. Like there's a reason why, what Google's doing to change effectively killing dynamic ad blockers with Manifest v3 and everything going on in the browser space, right? Like Google has basically announced like a war on ad blockers because it is their core business. I mean, you listen to their earnings reports, the majority of their revenue comes from their ad business. And it's been that way forever. And so, yeah, I mean, I feel like the internet's become one big advertisement, and now I'm going to have AI chatbots recommending me products too.
Yeah, so to be fair, I think obviously they could have it as a little sidebar on the
Sure.
website or in the
Yeah.
app or something. Click it if it comes up. But conceptually, we started talking about data uh, governance and security and stuff like that.
Hmm.
I mean, clearly, the Google today, Google search is the place where intention becomes action. You say,
Hmm.
where should I go for dinner? You go search, Indian restaurants near me, and off I go. And I know like the rating out of 5 stars influences my decision based on how people are out there.
100%.
So I get influenced all the time by this stuff. And the concept of people paying to play, concerns me, but it's a reality of the world we live in. The concept of using a model to run ads because that's what's replaced the interface to search. You're not doing Indian restaurants near me. You're talking to Perplexity with, your phone, or you're typing it in and it's doing the search, and it's more of an interactive back and forth. Which one's got the best butter chicken? Okay, I'm going to go there,
Hmm.
whatever.
Yeah.
The idea that, I'm doing research for a new car, and um, the gas mileage of the Nissan TM is part of the response that's served to me from a language model, I think is too hilarious to me to ever get put into the reality we're living in.
Hmm.
But that's just a hope, man. I mean, they could easily be RLHFing these models towards certain products and services that are, all right, guys, the sales team just closed a nice deal with this new balloon manufacturer. And anytime somebody's talking about a birthday planning, let's start promoting the certain parties.com or whatever this balloon place would be. I don't know. It's just like, and we're going to run it for 6 weeks and then take it out. It's like,
So,
I don't get
yeah,
it.
I mean, and then like where does the evolution of that go? And what I mean by that is, do we now just have AI that can already ghostwrite emails for us? Can already now, recommend us products. at what point does email spam just become completely AI driven, right? Where like we're just saying, okay, model, you're focusing on this for the next 6 weeks, run this campaign. Um, I mean, this gets into like a much deeper conversation, I think, about how just advertising in general changes,
Hmm.
and the way that we think about and are influenced by advertising. And much like we started this week's episode with talking about how ChatGPT has influenced the way that we speak and the way that we think and the way that we write, to a certain degree, at least the people that use it quite often. Uh, at what point where do we draw the line on using AI for advertising? Because I'll tell you a quick story. McDonald's years ago got a lot of shit for this. They tried to do a subliminal messaging ad on TV where they're just showing footage of something, and every once in a while they flash the golden M, right? Really quickly, like barely perceptible to the eye. Like, at what point does AI based advertising get to that level where we're just having a conversation with AI and you're like, shit, man, I really want McDonald's right now?
Yeah, 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 yeah. That's, well, I can't think of a better way to wrap it up for this week. So let's leave it at that, man.
Yeah,
Nice job.
sounds good. Yep,
Talk to
see
you
you
soon.
next week.
Bye.